Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Solvolysis of a secondary benzylic triflate, OTF, under nucleophilic conditions. Step 1. Identify the substrate. The starting material is a secondary benzylic triflate. The carbon-bearing OTF is attached to a phenyl group and an ethyl group, making it a secondary benzylic carbon with the S configuration. Triflate, OSO to CF3, is one of the best leaving groups known in organic chemistry. Step 2. Identify the reagent. CH3O, methanol, at mild heat, 30 degrees Celsius, is the solvent nucleophile. Methanol is a weak nucleophile, but the reaction is run in excess methanol, solvolysis conditions. At 30 degrees Celsius, the conditions do not strongly favor elimination over substitution. Step 3. Reaction pathway. Because the carbon bearing the triflate is secondary and benzylic, ionization to form a stabilized benzylic carbocation is very facile. Triflate is an excellent leaving group. The benzylic carbocation formed is stabilized by resonance with the phenyl ring. In the presence of a nucleophilic solvent, methanol, SN1 type solvolysis, or direct SN2 leads to substitution. Methanol acts as the nucleophile, attacking the benzylic carbocation, or the back phase in SN2, displacing the triflate and forming the methyl ether product, PHCH, OCH3, CH to CH3. Step 4. Why substitution predominates over elimination at 30 degrees Celsius. Elimination, E1 or E2, is favored by strong bases and or high temperatures. Methanol at only 30 degrees Celsius is a weak base. The mild temperature and nucleophilic solvent favor substitution, SN1 solvolysis, rather than elimination to give styrene derivative, option B. Step 5. Evaluate other options. Option B. Beta-methylstyrene. This would require elimination, E1 or E2. Under these mild conditions, weak base, 30 degrees Celsius, elimination is not the predominant pathway. Option C. PHCH, OSO to CH3. At this would require exchange of the triflate for a mesylate group. Methanol cannot act as a sulfonyl transfer agent. This product makes no chemical sense under these conditions. Option D. None of these. Incorrect because option A is the expected product. Step 6. Conclusion. The predominant product is the methyl ether PHCH, OCH3, CH to CH3, formed by SN1 solvolysis of the benzylic triflate with methanol as nucleophile. This corresponds to option A. Therefore, the correct answer is A. Therefore, the correct answer is option A.